Namaste to all. In the previous session, we concluded what are the operations that can be performed on discrete time signals with respect to time scaling, time shifting, and time reversal. These three operations are common to both continuous as well as discrete time signals. So those two topics are concluded in the previous topic. Now in this topic, just we are going to make operations on signals with respect to amplitude concept. No need to confuse. In the previous case, we discussed operations on signals with respect to time domain. Now here we are going to discuss operations on signals with respect to amplitude domain. So let us start. Now let us start. As discussed in the previous class, we know that whatever operations that can be performed on signals, there are operations can be performed in two parameters, in two concepts. One is called with respect to time and another one is called with respect to amplitude. These two are these two. So with respect to these two parameters, we are going to discuss the operations on signals. Here signals means both the continuous as well as discrete time signals. Now just we concluded operations on signals with respect to time. Again, just I am informing you, time means what? Time shifting, time scaling, and time reversal. So these three concepts are already woven in the previous sessions. Now in this session, we are going to discuss operations on signals. Signals means both continuous as well as discrete time signals with respect to amplitude only amplitude. Now regarding amplitude, now here this is operations on signals with respect to amplitude parameter. First one. The first one is called amplitude scaling. The first one is called amplitude scaling. The second one is called addition operation. That means addition of amplitudes. Here this word you have to make it of amplitudes. Addition of amplitudes. Now third one, multiplication of amplitudes. Next one, the third one, fourth one, that is subtraction on amplitudes. Now these four operations here we are going to discuss in this session. Again, just look at two kinds of operations can be performed on signals. Here signals means as a whole we are talking of, but students have to understand that signals means both continuous time signals as well as discrete time signals. So what signals? Two kinds of operations. That is, one is with respect to time domain, another one is on the basis of amplitude. In the previous sessions, we already discussed whatever and what kind of operations can we make on both continuous as well as discrete time signals. That is over. Now we are going to start operations on signals with respect to amplitude parameter. Under this amplitude parameter, there are four operations. The first one is called amplitude scaling. Now just look at. Let us consider a continuous time signal, sketch of a continuous time signal. For example, look at amplitude is equal to 2. It is from -3 to 2. This is the continuous time signal. They ask you now, what do you mean by x of 2t or x of 3t? X of 2t or x of 3t? Wait. Now, here they ask you what is 2 times of x of t or what is 3 times of x of t. either this or this they ask. Here, very important concept is there, students have to differentiate between, very, very important concept. Most of the students confused here. For example, 2 times x of t is different, x of 2t is different. This is very, very important concept. 2 times x of t is different, x of 2t is different. I will tell you the difference once this concept is over. Now just look at, let us start with one. The first one is called what? 2 times x of t. Now here in the given graph, what is the width of the signal? Width of the signal is belonging to between -3 to 2. That is the width of the signal. Here just look at, the concept is with respect to amplitude. So we have to concentrate only on the amplitude. There will be no change in the width of the signal. Here the main focus will be only on amplitude. Every signals are having both width and amplitude. But the concept is which one? On the basis of amplitude we are talking of. That means what? What is the width of this signal? -3 to 2. There will be no change in the width of the signal. No change. So where the change we can get? We can show, we can experience the change in the amplitude only. That's why the title is amplitude scaling. Only amplitude will be scaled. Amplitude will be scaled. There will be no difference between width of the previous signal and the present signal. Now just look at 2 of x of t. 2 of x of t means what? In the previous case, what is the amplitude? In the previous case, the amplitude is what? Amplitude is equal to 2. Now this amplitude multiply with 2. In the new one, in the new signal, the amplitude is equal to 2 times 2, that is equal to 4. So now just look at, the graph will be like this. The graph will be like this. This is 2 times of x of t. Now what is the width? The width is -3. Here it is -2. In the previous case amplitude is 2, but now amplitude can be 4 times. So the sketch will be like this. Look at the difference between these two sketches. In the previous case, the width is between closed interval of -3 to 2. Here also the width is, here also the width of new signal belongs to which one? -3 comma 2. There is no change in the width of these two signals. The change is experiencing only in terms of amplitude. In the previous one, in the given one, the amplitude is 2. In the new one, the amplitude is equal to 4. Now try to understand where you can find the change. We are finding the change only in the amplitude, but not in the width of the signal. In the similar way, just look at, what is the graph of 3 times x of t? This is t, this is x of t. Now same, what is the width of the graph? -3 to 2. There is no change in the width. So that is -3. This is 2. Now in the previous case, what is the width? 2. Now 2 should be multiplied with 3. That means what? 6 times. For example, so here is the 6. So now the signal will be like this. Will be like this. Now just look at, students have to compare this given signal, this signal and that signal. All these signals, which one is common? Which one is common? Well, the width is -3 to, -3 to, -3 to. There is no change in the width, but where you can experience the change, only you can experience the change in terms of amplitude. But what kind of amplitude? Amplitude scaling. Amplitude scaling means what? Amplitude multiplication of amplitude, not coming down, only going up. So this is called amplitude scaling. In the previous case, the amplitude is 2. Here it is 4. It is 6. There is no change in this one. So this is very important concept. Students have to make it. Okay? I think it is clearly understood. Now come to this point. What is the difference between, for example, 2 times x of t and 2 times x of t and x of 2t. Look at x of t is a continuous time signal. Here x of 2t is a continuous time signal, but the 2 is within the parameter, within the parenthesis. Here it is 2 is what? 2 is multiplying the entire signal. Look at 2 times of x of t. Here we are multiplying the given signal with the numeric number 2. But here the signal itself is x of 2t, lot of difference. What is the difference? Now just look at here, just what we discussed, this is called what? This is amplitude scaling, just what we discussed. This is called what? Amplitude scaling. Amplitude scaling. Look at all these cases come under the concept of amplitude scaling. That means the change is only in the amplitude but not in the width. Now here just look at amplitude scaling. Amplitude scale means what? Width, no change. Width is no change. But change is in with what? Amplitude changes. Amplitude changes. Now here come this one. This is x of 2t. What is this one? Scaling. Time scaling. It comes under time scaling. In time scaling, what is this factor 2? 2 is what? Greater than 1. Greater than 1 means what? The signal will be compressed. Signal compressed. Signal will be compressed. Here, amplitude. Look at amplitude, no change. Amplitude, no change. Now here, width changes. Width changes. Very important concept. Look at this one. Very, very important. Once you come to know, then only you can understand all the topics in the next applications of signals. Now x of 2t as well as x of 2 times x of t. Again just look at, you call this as amplitude scaling, but you have to call x of 2t as time scaling. Time scaling is different. Amplitude scaling is different. Both are scaling with respect to time parameter. This is with respect to amplitude parameter. Here, what is the scaling factor? 2. Scaling factor is 2 means what? Greater than 1. Greater than 1 means what? Signal will be compressed. We already discussed that. X of alpha t is a scaling signal. Here, if alpha is greater than 0 and less than 1, what happened? Expanded. Expansion. If alpha is greater than, what happens? Compression. Compression means what? Reduction. Reduced. Now just look at 2. 2 is what? Greater than 1. Greater than 1 means what? Signal will be compressed. It will be compressed. In the compressed sense, where student can get the difference. Student can get difference only in the change of the width. Width will be changed, but no change in the amplitude. But here in amplitude scaling, the name itself indicates changes in what? Amplitude, but no change in the width. These two students have to swap these two one. Look at 2 times x of t and x of 2t. These two are different. Width factor, amplitude parameter, amplitude factor. Now width, no change, but here width changes, amplitude changes, amplitude no changes. This is called amplitude scaling, that is called time scaling. That is called time scaling. Now these are the differences between these two of signals. Now just again come to the factor that what kind of operations you can make on signals means 2 kinds of operations. One is with respect to time parameter, another one is with respect to amplitude parameter. Under amplitude, we can exercise how many operations? 4 operations. Just now a topic is concluded. Which topic is concluded? Amplitude scaling is completed. Now in the next session, we are going to discuss operations on addition, multiplication, subtraction. With respect to which one? Amplitude parameter. Thank you very much.